I have two triangles right here, and let's give some information. Let's call this ABC, and I don't know, let's go XYZ instead of DEF every time. Is that better?
Yes.
Okay. All right, so I've got two triangles right here. Let's give some information. Now, so far, until today, you've learned two ways to prove triangles congruent. What was the first way?
Side, side, side.
Good. And what was the second way?
Side, angle, side.
What's up with that angle? That angle had to be what?
In the middle.
Yeah, not in the middle. What's word have I been using lately? Yeah, included angle. Good. It's the included angle, all right? So watch. If I was given this side and this side, the angle would have to be between, or the included. The word that they use is called the included angle, all right? So if I gave this one and this one, the angle for side, angle, side would have to be the one that attaches those two sides to each other. Do you see it? But that's not what we're doing today. We are going to learn two different ways. And these, by the way, were all what? Postulates. And what's true about a postulate?
They're always true.
Right, they can't be proven, you just accept it as fact. Okay, now today what we're going to do, one of the things we're going to do is a postulate, the other thing we're going to do is a theorem. And what can you do with theorems?
Prove them.
You can prove a theorem. And we're going to kind of prove a theorem today, not really an official proof of the theorem, just kind of explain it a little bit. So here's what we're going to do today. Here's the other postulate. We actually have three postulates. And I got to make sure, yeah. So there are others, but right now we're only going to do three. So let's say I was given this angle was equal to this angle, and I was given this side is equal to this side, and I was also given that this angle up here, A, was equal to this angle over here, X. Now, up to this point, that wouldn't mean anything to us, would it? But there is a postulate that says, guess what?
Oh, no.
What do you think? What do you
Side,
think
angle,
we'll call
side.
it? Side, angle, side?
Angle, side, angle.
Angle, side, angle. That's right. And that's a postulate. So if you say, well, prove it to me, well, I can't prove it to you, but because it's a what?
Postulate.
Because it's a postulate. But we'll throw that in our little list.
I don't really think
Of
we'd
postulates.
question it if it was already proven.
Yeah. So watch this. I mean, if you wanted to, you could do this. I mean, you could take like little sticks or little lengths of whatever, you know, and make sure that this length was equal to this length, but make sure that you made this angle, right, between this other side, this unknown side, and this known side equal to the same thing over here. And make sure that these two angles are equal to each other. Because think about it. If I took these, if I lengthened AC, what would I have to do to BC in order to make it a triangle? I would have to lengthen that. Plus, I'd also have to do what? Change the angle, wouldn't I? Okay? So is there any way to change these, given this angle and this angle and this side, is there any way to change it so this triangle over here could look different than this? There's really not, okay? That means that they're going to be congruent to each other, all right? So that's just one of our reasons. That's basically it for that, all right? That's angle, side, angle. Now, what if you were given, let's get rid of this and this. What if you were given those same two angles, but you were given this side, AC, was equal to XZ. Is that one of our postulates up here?
Yes, sir.
No, because that side is not what? Give me the word. Included. All right, this side is not the included side, is it? So I've got two angles and a, what do we say, a non-included side. You follow me? So angle, side, angle is what? Two angles and an
Side.
included side. Got it? This right here are two angles and a non-included side. Now remember what I said this was. This was not a postulate. We could actually kind of prove it a little bit. Why is this true right here? Well, let's think about it a little bit. Let's go to a different color just so that it... Okay. Nope. Watch this. We talked about this yesterday. If I have two angles of one triangle equaling two angles of another triangle, talk to me. What do you think must be true about C and Z?
They are congruent.
They're congruent to each other. Why? Give me a reason.
All angles.
Third angle theorem, okay?
Yeah.
Right? So I'm going to put 3 right here, even though it's in a different color. Does that look like a different color to you on the screen?
Nope.
Yeah.
Okay.
Rainbow.
If you look at it on the computer, it definitely looks like a different color, but on the screen, sometimes you can't tell the difference. But anyway, watch. If these two angles are equal to these two angles, guess what? The third angle must be equal to each other as well. Why? It's because of the third angle theorem. Now look at this. Forget the new theorem that we're learning. Just think of these three right here. Are these triangles congruent now? Yeah, because of what?
Side, angle, side.
Why do you keep saying side, angle, side? There's only one side. There's only one side.
Angle, side, angle.
Angle, side, angle. You see it? So really, I took two angles and a non-included side, and I said, okay, the third angles must be equal to each other, right? Because third angle theorem. So guess what I have now? I've got angle, side, angle. So that's kind of like a proof right there, what we just did. We kind of proved that, oh yeah, these triangles are congruent really because of what? Angle, side, angle. But here's the thing. Why do we even make that a theorem? Because do I even have to say anything about these two other angles down here? I don't have to say anything at all. I could just state, what? What do you think we would call this one?
Angle, angle, side.
Angle, angle, side. That's right. And angle, angle, side is a theorem. Angle, angle, side is a theorem, right, that can be proven. We kind of did the proof. What was the proof? I made those third angles equal to each other because of the third angle theorem, right? And then I said these triangles are congruent because of what? Angle, side, angle. All right, that's kind of your proof. That's basically, in a nutshell, your proof to prove that these two triangles are congruent to each other. Does that make sense?
Yeah.
All right, so, but we can do this. Instead of going through all that, I can just look at the information that's given. I can just go through this information that's given right here and say that these triangles are now congruent because of what? Angle, angle, side. You get it? So I can have angle, side, angle, and I can also have angle, angle, side. And those are my two new theorems. Now we have four different ways, don't we, to prove that triangles are congruent to each other. We have side, 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 angle, side, angle, side, angle, and angle, angle, side. Not too bad, is it? All right. Let's do a little example, and then I'll let you do some problems on your own, okay? All right, here we go. We got our little picture. We got all the stuff that's given, what we want to prove. Let's mark the stuff. Let me go to red right here. We've already marked the parallel lines. GH, this top one, is parallel to FJ, so I mark them with these arrows. Angle G and J are equal to each other, and they're both equal to 90 degrees. We do have a chapter a ways from here that that says when you have a what is the word? Parallelogram. We'll talk about this later, but just to get you thinking. If you have a parallelogram, the opposite angles are always equal to each other. All right. So,
Really?
yeah, if you have a parallelogram. But so anyway, this given says that those angles are equal to each other and they're both 90 degrees. Got it? And let's see. And we want to prove that these two triangles, FJH, this triangle down here, is congruent to this triangle right here. Let's go through it. Well, look at it. The only thing I know right now are this angle, right? All I know is this angle and this angle are equal to each other. But, say it, Rachel, I know parallel lines cut by transversal, so we should know some stuff now, don't we? Okay, so what do you think must be true about this angle GHF? That would equal what?
F.
Not F.
HJ.
HFJ or JFH, this one right here. You see that? Would you agree? What's my reason for that? Alternate interior angles. Exactly right. I got alternate interior angles. So now look what I have. Now I have two angles, don't I? I've got this angle and this angle, and this one and this one. Do I have to say that this one and this one are equal?
Nah.
Don't have to. I could if I wanted to, but it's kind of a waste of time. All right, so I don't have to say that this angle right here is equal to this one. Wouldn't be difficult. It'd be easy because they're equal to each other. Well, let's see. Not because of alternate interior angles, though.
Complementary.
Because, look, do I know that this line and this line are parallel?
Nah.
I don't know that, do I? So I can't really say that this and this are equal because of alternate interior angles, but I could say they're equal to each other because of... I got two angles equal to two angles. Say it. The third angle theorem, right? So I could say that this angle is equal to this one because of the third angle theorem. But I don't need it because what do I have already? I've got an angle. I've got an angle.
Included side.
Well, do I know that this side is equal to this side?
Yeah.
I do.
They're parallel.
That doesn't mean they're equal to each other in length. Just because they're parallel to each other doesn't mean they have the same length.
It's because of the 90-degree angles.
No.
That doesn't have anything to do.
Maybe if you guess.
There's something that's pretty obvious. What do you think? If the angles on both sides are equal, then what? I lost you on that. The line in the middle? This one?
Isn't that considered?
Let me give you a big hint. Look at this line right here.
Reflexive
Talk to me about
property.
this. Yes, yes,
The reflexive
yes.
property?
FH equals FH. That should be one of those things that just pops right out at you, okay? So look for that. It's shared by both of these triangles, isn't it? So that's what I would look for. As soon as I saw this, first thing I saw was FH equals FH because of reflexive.
I saw that. Yeah.
Did you see it? Okay.
Good never
So now look, are these triangles congruent now?
Yeah.
Angle, angle, side. Okay, angle, angle, side. So yes, they are. Yep. So angle, angle, side is what you would write AAS, but you would say angle, angle, side. All right. I don't have to write all that out, do I? I pretty much went through the steps. Remember, the only thing that you really have to give a reason for is this, that this angle and this angle are equal. And what was our reason? Alternate interior angles. Okay? Oh, this one right here you had to give a reason to. FH equals FH because of reflexive property. Reflexive. Okay? REFLEX. Okay? Not reflective, reflexive.
I like that.
You got it? Yeah, that's a nice little property that's easy to see. All right, well, that's good.
Let's do another one.
Why don't you do some on your own?
All right, that's a great idea.
Let's do page
I'd love to do
277. And we're going to do 6 and 7. Oops.
this from homework.
9. Yeah, it's classwork and then homework. Tell you what I'm going to do, though. I'm going to go to YouTube just to show you, just to demonstrate how much stuff there is on YouTube on proofs. If you get stuck, you need to see some extra examples. All right, use YouTube. I mean, YouTube is a great resource. You wouldn't believe. I mean, we need to, especially math teachers, need to really get you guys looking at YouTube if you have a question. If you don't know how to do something, I would go right to YouTube. Not to necessarily to my page, all right, but do a general search for what you're trying to look for, and it's incredible what you'll find. So it's a section 4, 5, and these are the ones that you're working on right here.
It's about time we got
Okay.
those fives.